So that's what? The air's going that way. It's not going this way. Okay. Just a fair request.
I feel like the air was on like the air.
Yeah.
Also,
All right, I'm going to say 20 minutes.
Those are pointing upwards. That's probably why you don't float
All right, so that's JSON. We made JSON into. This is good. Sorry. So Sam, what does JSON stand for? Nice. All right, hold on, I'll be right back. JavaScript object notation. And Sam, where have you encountered blobs of information? I just swear I'm not sighing, it's just very. Where have you encountered things of JavaScript object notation? In what? In Postman, cool. And when you're in Postman, like, where is that information coming from? It's coming from an API. And when you hit an API, how are you finding the location of that API? Nice. URL, which stands for what? Nice. It's uniform resource location, just somewhere. Main word there is location. It's somewhere you're looking for something. What is that thing? The thing is a resource. What is a uniform? It's just saying this is a specific format that is used all throughout everything. Oh, damn, what a good explanation. What does uniform mean to you, Allison?
That's so weird.
Okay, so the Catholic school thing, why do they call that a uniform? Because everyone has to wear it, that's right. URL is a specific pattern of laying out a location that everyone uses. That's what makes a uniform. Say it louder.
Is it uni coming from one? So
Uni?
one is one.
Uni coming from one. Do you want to do a Latin lesson? What? Because you knew the word. Uniform, one form. There's one way of doing this. Cool. So Sam, you looked at a URL in order to hit an API and get some JSON. What was that URL looking at? Like, what is that location itself? On the highest level. Website, okay. Might not be a website, but what is it? What's a website? What does a website have in common with the server, with another thing on the internet? Do you know where a website comes from? A website comes from the internet. But what is the internet? It's a collection of tubes. Maybe I haven't been saying that. That's very true. Kind of is. But the internet connects what? What is everything on the internet ultimately? Every different location that a URL might point to. Computer, yeah. So every URL points to a computer somewhere. Cool. How do we find a computer, Angela? What information can we find out about it? What's that? An IP address. What is an IP address? Good writing. Angela, what is an IP address? The actual location of the computer. What does that IP stand for? It's okay to guess and be wrong. Internet protocol. I think so, yeah. Sounds all right. Have you guys ever gone to the web and said, I want to go to Facebook, so I'm going to type in 127.98.9333.094?
Yes.
Jack, how do you remember all those numbers for every website you log?
Look at our DNS.
You look at the DNS. Okay, what's a DNS?
The domain name server.
The domain name server.
It's basically the phone book.
The IP phone book. So when you go to a website, you're using a domain name, which is just an alias for an IP address. We go to facebook.com, we go to the phone book says, oh, you were trying to get to facebook.com. That's this set of numbers. I'm going to go find that thing's location. We did so much this week. It's still Friday. We've still got more to do. So, that's some stuff. What's this? Kimball.
Hypertext transfer protocol.
Hypertext transfer protocol. Neat. Cool. What does that mean?
So just the set of instructions that translates stuff written on the circuit to the client.
It's a set of instructions that lets you send information on the internet. It said those two words though. What were the? It sends the what to the what?
Hypertext to the
What are the two locations you're talking
server and client.
about? Ooh, what are those?
Server is the computer that the website is at that delivers information to the client. And the client is you.
So they actually both send information, internet speaking wise, but what kind of information is each sending? They both of those things start with an R. So who sends a request? Cool. Clients send requests to servers, and what do servers do after that? It's in our word.
Respond.
Yeah, a server responds. What do we call that response? A response, that's right. Sorry, I gave you away. Clients send requests to servers, and servers respond to clients' requests. Again, this is literally just taken from a service industry or a customer service like situation. Computers don't exist without human beings. All the analogies are ultimately made by human beings. Some are bad, some are good. This one's pretty good. So just think of this real world example. So, using the hypertext transfer protocol, clients make a request to servers. Servers then also use the hypertext transfer protocol to send a response. Those are just messages between them. This is a specific format that has been set up between computers. Servers and clients are both computers on the internet. They have IP locations, IP addresses, They probably are listed in the domain name server. And if you're getting information from a computer in response to your request, you could probably treat that computer like an API, because you don't need to know anything about it in order to get data from it. You've used APIs. Use them all week. Today we're going to talk about how to actually use this in your app to get that information from APIs. Up till now, we've gone and we've used a third-party software called Postman. We've said, hey, I know where the thing is that I want. Like, can you give it to me, and then I'll just literally put it in my app, and then I'll figure it out from my app. Postman obliges, but it might be even easier if we didn't have to go to Postman to get that information, but instead have our app do that for us. Before we do that, specifically for iOS development, does anyone know what HTTPS stands for? Secure. Secure. HTTPS, Hypertext Transfer Protocol Secure. It's like the SEC is the evolution of HTTP. It's like the next standard. It is not the same thing as HTTP. It is an attempt to make Hypertext Transfer Protocol more secure. That is important for your iOS apps because starting a few years ago, Apple said, if you do not use a secure protocol for fetching information, I will not let you have information. So if you make an HTTP request within your app, unless you change a setting that I'm not going to show you today, because we're just going to focus on using HTTPS, unless you change that setting, you cannot get the information. I'm going to block it. I'm just going to outright say you can't make an HTTP call in your app. So, our API calls need to be secure. We need to be using HTTPS. Neat. One last word. Asynchronicity. Noticing it as async. Does anyone have any idea what that means? Nima, give it a try. Not in sync. I like it. What do you think that means in terms of networks, in terms of requests and responses, in terms of the internet? What do you think not in sync means? Yeah, I like it. So I'll tell you this. Computers are obsessed with this. So this line is called time. Computers are obsessed with time because computers are made by people. People are also obsessed with time. If you are synchronous, that means you are happening in an order. You define order. This is it. So you start doing something, you end doing something before you do the next thing. Like being in sync is kind of like completing all your stuff and like covering your bases when we talk about it with human beings. In terms of time or computers, like you start the thing and you end the thing before you do the next thing. That doesn't work when we are getting stuff off the internet. Anthony, why don't you think that works? Like, this looks nice and tidy. But why would we maybe do it a little differently on the internet? Okay, give it a guess. Yeah. So Sync wants to do 4 things. Sync wants to, say Sync is a farmer. Sync wants to wash himself. Sync wants to bale some hay. Sync wants to herd all the sheep. And then Sync wants to make dinner. Those can all be done in order. The internet doesn't work that way for a very, very important reason. Okay, think about it like this. What if there were 4 apps that did those things? Would you have any guarantee that they would all stop before the next one starts? So your watch app, you say, begin watching. And then you have to wait until that ends, even though you have no responsibility or control over when that ends, before you can go and bale some hay by pressing the bale button, your bale hay app. Because on the internet, I don't know if you've ever seen this, but sometimes when you go to a website, it doesn't load as quickly as you expect. See that? Because part of interacting with other computers is the fact that you don't know precisely how long it's going to take to get something in response, whether you're going to get something in response, what kind of trust you can have of those things. You use an asynchronous pattern where I might say, okay, I'm going to start watching, and then eventually that's going to end. But in the meantime, I'm going to start baling hay. Eventually that's going to end. So I'm going to send off multiple requests at once. Might do that. And then if I send those multiple requests at once, when I finally get a response, then I'm going to do something with it, but I'm not going to sit around waiting with my hands under my bottom. I'm not just going to sit twiddling my thumbs, right? So an asynchronous request is one where it doesn't necessarily need to be in order with some other requests. You might do some stuff in response to the completion of that request. You might say, okay, when I watched, I couldn't possibly feed, what do you, hay? Is it cows? Cows eat hay. I think cows, right? Horses? Thank you. What's a horse? Is that the one with the 4 legs?
Yeah.
Okay. I couldn't feed the horses if I haven't baled the hay. So I might not be able to start feeding the horses until I get a response from baling the hay. But I'm not going to sit and not do anything. Life lesson. If you're waiting for an answer from something, you don't have to sit and wait to just get that answer. You can do something asynchronously and start something else.
Like going on Google.
By going on Google? Ooh. Yes, by going on Google, or not going on Discord, something like that. Sorry. So yes, some things need to be synchronous. Some things need to happen in an order, but not all the time. So I've got, let's say, a tab bar view controller where I'm loading up, I don't know, some trivia, some jokes, and some Star Wars stuff. I might send 3 asynchronous requests to some APIs saying, let me get all that information. Each thing can operate separately. They can be asynchronous. What probably needs to be synchronous is, if, say, you were creating that tab bar controller with 3 table views in it, you're probably not going to load the table view until you get that information back. What's a way that you can check in Swift that a value is just set? Like, let's say I made a request, which we're going to do, I promise. I made a request, and then after I made that request, the information came back, but now I want it to be in my controller, and then I want my controller to respond to it, to respond to a property changing. What's something we could use? A property observer. Interesting. Jason, what's a property observer we know and love? Did set. Cool. Who doesn't know what did set does? Does not. Okay, good, because this is super important. If I've got to erase some space on the board, so let's say I've got a variable in that tab bar view controller. I've got a variable in one of the view controllers in my tab bar controller. Var jokes. That is an array of jokes. It's an array of jokes, right? Today we're going to make network requests, so we don't know how long it's going to take for things to come back, but eventually I'm going to make a call to a jokes API. It's going to get me that information, and I'm eventually, somewhere in it, so there's a function get jokes. Eventually, if all that decoding stuff goes well, and there's success, I will set self.jokes equal to that remote jokes. The reason we use property observers like did set is we want to say, okay, right at this moment, we got the value from our remote API. So we went out onto the internet and we said, get me those remote jokes, get me that stuff from somewhere else. The reason for the property observer, so this did set, for example, so we want to say, if you just set this value, do some stuff here. Like if you just changed it, I want you to please do something that affects maybe my UI, affects other models, other view controllers. If we are making a table view here out of jokes, what do you think I would do in my did set, Mario? Like, just pseudocode it. Yeah, so let's say before I had no jokes, and now I just got this remote jokes was like 15 jokes. What can I do in my controller to show that in my table view? Let's say we set that all up before, like all the data source stuff is set up down here. You know, you've made a table view before. But now I want that table view to update and say, I know you've got it all diagrammed out. I know your data source. I'm sorry? Yeah, I want to load, reload which view? Cool. Allison, do you know a function on a table view that lets you do that? Nice. So if we just set the value, for jokes, this property observer is literally saying, if this value was just set, do this. I'm sorry, do this. And that's instead of here calling a separate function to do that. A better way to do it would be to have a direct line, like an actual chain reaction, where if you set something to jokes, so if I change this property, if I did set, if I assign some value to jokes, do this stuff. That's a property observer. It's saying if you did set the value for jokes, do that. Has anyone seen another property observer before? Aaron.
Yeah, there's two of them.
Think about the verbs we use.
What's that?
Jason, I see you. What was it? Will set. What do you think that is?
You change the variable or access the variable. Not sure.
Okay. Remember that even though they work really quickly, computers work in time. So let's say I've got a variable a, which is equal to 1. And then here I say a is equal to 2. Here's the timeline of that. At this point in time, a is equal to 1. At this point in time, a is equal to 2. You can think of did set as right here. So right after that value was set, or literally triggered by changing that value. You can think of will set as right before. Computers work in the same time that humans work in. They just happen to work faster. Neat. What are some questions you have? So I was watching Jackie yesterday, and she was like, I used to be a teacher. You just walk around, people's eyes follow you, they pay a little more attention. So I'm just going to pace for the rest of the day. You guys can ask me whatever questions you want. That's true. Rob. So another way to think of it might be that in a synchronous line of operations or requests or whatever it is, when you're doing things in sync, like synchronously, you start and complete one thing before you move to the next one. And that's because, generally, in this situation, those things need to be done sequentially. In async, you have a set of operations that don't need to be done sequentially. So, going out and getting Star Wars data yesterday, and going out and getting joke data. Those aren't dependent on each other. They can be done asynchronously. So, if I've got something responding to Star Wars data, that doesn't depend at all on there being any joke data. Those things are asynchronous. Those two processes don't have to be done together. You got it.
Is that how people that yesterday and retail is that how that works?
Is that?
Because we're doing three APIs separately, right?
Technically, yeah. The requests you were making were not to like some remote IP address, but instead they were decoding JSON files that you have. But they were asynchronous because you didn't load Star Wars and joke data at the exact same time. You loaded them at different times. The super important thing about asynchronous operation is you are waiting for the response to occur. You don't know when it's going to occur, so you have to wait for that and respond to it in certain ways in your code. For example, using property observers. So if you went out and you got the joke data, and typically in your table view, you said, okay, load this immediately. But the joke data took like 6.5 seconds to get. Like, everyone take out your phone. Do what Ayula's doing. Take out your phone. No, it's okay. It's okay. It's okay. This is a good example. This is a good example of the internet. Everyone take out your phone. Open it up. And now stare at the screen. I'm going to count to 6 seconds. Ready? 1, 2, 3, 4, 5, 6. That is a lifetime in phone time, right? That's an incredible amount of time. 6 seconds is super lag, right? You would turn off an app that made you wait 6 seconds for something. But you never know how long things are going to take. So you have to do these operations asynchronously because you don't know when it's going to come back. Certain things depend on it. But you can do other things in the meantime. You don't want to be sitting there waiting for it to complete before you do other stuff that doesn't depend on it. So like, I've run out of analogies for this portion of the class because we definitely need to take a break. But asynchronous operations don't need to be completely sequential. It's the really big important thing. And when we talk about asynchronous operations in the context of web, we're saying my request can go out there, and when I get it back, I'm going to do some other stuff with it. But for now, there are plenty of other functions I can run in my app. Dee and then Michelle.
Well, you kind of answered my question a bit, because I was going to ask, when it comes to asynchronous and asynchronous, in like a real world setting, you would see mostly developers doing asynchronous, than more than the other. Okay, next question.
Yes. Michelle.
The did set violate when we're loading a page that sometimes takes longer for other things.
Yes. So the did set is saying, I might not know the order things are going to come in, but I want to set it up so that there is a direct chain reaction to setting a value in jokes. Let's take a break. The clock is behind me now. What happened? Let's hear it.
Stretching helps too. That's what I was trying to get your attention about.
Yeah.
Teach so fast.
Okay. Hi again. So, let's get that info off the internet. Let's go find it. We'll load it, put it in our app, and, that's it. We're done. You've made apps. The end. Let's learn about URL session, which is an object that coordinates a group of related network data transfer tasks. Albert, what do you think that means? What do you think a URL session is, Sam? What do you think it does? What do you think it is? Tell me about it. Okay. Take a guess at it. What do you think we're going to use it for? Interesting. Interesting. To have a session of a URL? Let's see. Ooh, the URL session class and related classes provide an API. Wow, this thing itself is an API. It's an API for downloading data from and uploading data to endpoints indicated by URLs. The API also enables your app to perform background downloads when your app isn't running, or, in iOS, while your app is suspended. What is that? A rich set of delegate methods support authentication and allow your app to be notified of events like redirection. What does delegate methods mean? Has anyone seen that before? You have? All right, well, you said yes. Why don't you tell me what it means?
When we're doing something, like when we're typing something in our
Cool. I like it, but I don't love it. That's okay. Do you want to ask someone to help you with that? All right, I'll do it. It's like when you delegate a variable from a class to another class. Yeah, that makes sense to me. Tell me why we do that, though. Okay. I'm sorry? Because I told you to. So, when you go for a job interview and someone says, what is delegation? You're going to say, it's a thing our instructor said to do. How do you think that's going to go? Okay. Yeah, the good thing is I'll know everyone that you were ever interviewing with, and they'll all know me. Hey, Kevin. Can you help me figure out what this delegate methods thing means? Where do they come from? Cool. URL session itself gives you those capabilities. Just want you to keep in mind at a high level what a delegate method is. It's providing the functionality to something else. You're going to see delegates all the time. It's not just going to be, am I typing in a text field? Delegates exist all over the world. That's not really helpful. Delegates exist in many different contexts that you'll be coding in, such as in a URL session, which is what we're using to get and send information to remote URLs. So these delegate methods support authentication. What's authentication, Sunny? Making sure that something is correct. I like that as a very good explanation. What is an example of authentication you've seen with like computers? Interesting. Unit testing as authentication. I'd say that's verification more so than authentication. Jack, I can see your mouth when it moves. I just want you to know. Damn, you played me with food. Yes, authentication. So, have you ever seen like any of those dystopian movies? I know that's a really broad subject. Pretty much any media that's come out in the last like 10 years. Now like they track people, they authenticate people, they know who people are. Like Big Brother, yeah. Passwords are authentication, cool. You all authenticate, you all use some form of authentication every day to get into this office. What's that authentication? Your key card is authentication. Authentication is checking an identity or ensuring that something is correct. And in computers, that is the login process, right?
So like the device you tap is the delegator.
The device that you tap is the delegate, yeah. It's ensuring your identity. It is authenticating it exists. We're going to talk more about authentication next week. But URL session, this thing we're going to learn today, which really I'm going to show you very briefly and you're going to use yourself, is the thing that's going to let you do it. So this URL session lets you do such things as authenticating, and it allows your app to be notified of events like redirection. Yeah, what's redirection? Cool. I hate this phrase, but let's drill down on that. Let's talk about it in the context of computers. That's not going to tell you anything. Let's talk. I know.
But in the context of
Think about the internet. Nice. What is that called? Nice. When you get redirected to another site, it's redirection. sites are just computers, right? Or their information comes from computers, or an IP address, right? Redirection could be redirecting, could be a response from a server saying this is going to a different place as well. Redirection isn't just a web page. It's some response from some IP address saying this is in a different place. So to keep that in mind. Yeah.
I guess it's like, never done. I just wanted to just do dot whatever there. Dot.
So does the page automatically take you there?
No, it goes first page.
Yeah. And then?
My question is that like authorization? Like your computer also has to make sure that where it is that you're going is safe for you to go to and what you're actually asking for. So it goes good, and that's where like the URL will say, this may not have to be here.
Yeah. There is a form of authentication having to do with that area there. HTTPS. Has some, yes. Yeah. No, that. Sure. Does anyone remember what series of error codes are for redirects? What range was that? 300s. That's status code. 300 or 3XX, meaning somewhere in the 300s. Those are redirects. We're going to rewrite those codes, and we should do that all together because you're going to start actually seeing them now that you're using URL session. Okay. So, Alex, tell me again. What band
List
or
of codes or
what range of codes were you just telling me about?
300?
Cool. So,
It's around
3XX. Jocelyn, would you be able to tell me what range, like what 100th place do we get for status codes that are correct or that gave a successful response? I'm sorry? Awesome. 200. Successful response. Does anyone remember what a 100 response is? To the Southern delegate. It's an informational response. Is there a hand in the back? Sorry, I didn't see. No? Okay. No. Then there are two different bands, two different ranges for errors. B, give me one of them and explain it.
So basically, 400 is forbidden, and what that basically is saying is that when you go to the server, when you go to the website, you're unable to access anything, and that's you just going to the site, and if you go to 500, it's something based on the server side.
Cool. So let's look at those 400 errors. What B said was
Most common one would be 404.
404. What does that mean? Uh, 100 response. Mozilla. 400 response, bad request. Okay. Bad. Indicates that the server cannot or will not process the request due to something that is perceived to be a client error. What about 401? Can someone look up the name of a 401 response? Unauthorized? What do you think that means? What?
You're not allowed to.
Yeah, not allowed in. What about a 402? Has anyone seen a 402 error? I cannot hear you. Payment required. That's right. Payment required. There is a specific response, just like the one that Kimball found the other day for a teapot. There's a specific response for you attempting to make a request that required payment. We're not really going to work with payment that much, but you see it. You try to not pay for something. What about 403? Angela, what's a 403 response? Forbidden. We're going to talk about the main difference between 401 and 403 when we talk about authentication. Right now, if you think about 401, 402, and 403, you need a permission of some kind to get in. You're getting a response saying either you're not authorized, or you haven't paid, or you can't come in here at all. So these all require their own form of authentication. The last one you might see, 404. Olivia, what's a 404?
Error?
Yes. Let her try. Where'd she get up? Hey. Okay. Hurrah! What's a 404?
I believe it's valid response.
Valid response, something like that.
Or not found.
Not found. What does that mean?
Yeah, it was the response you sent was no longer, it's not valid.
Keep going. Keep talking.
There is no response for that, for that request.
Yes. So when we make a request, I'm going to move this away. When we make a request, it's generally to a URL, right? What is the thing in a URL? We have a location. What are you looking for at that location? You want to get some resource, right? Or you want to change some resource. You want there to be something in that location that you are using or interacting with. When you hear people talk about stuff on the web, they will refer to those things all the time as resources. So just get used to that word resource. A 404 means the resource could not be found. So when you're on a website and you get 404, it means the resource, which in that specific case is one web page, cannot be found. But 404s are response statuses for any URL. And not every URL returns some HTML from a web page. So 404, the very highest level, means whatever you're looking for in that location cannot be found. That resource cannot be found. Okay, let's use URL session. Ayla, do you want to lead the class? Okay, fine. Let's open up Xcode. Let's create a new project. Single view app. Intro to URL session. So my computer, I will drag it onto the other screen in just a sec. Sorry. You could if you want. I did. You could probably unit test some stuff. All right. So, you know what? Before we even do any of that, let's create a playground. The nice thing about working with our models in the way that we are now is that if we don't need to load them into the UI, if we just want to be getting stuff off the internet, we can work on all this code inside of a playground without putting it into an app. Weird, huh? But it kind of makes sense. If I just want to work on my models, so I've got a struct called people, which is got name, be a string. Then I've got var JSON, which is a multi-line string. Let's make a JSON. It's got opening and closing, braces. What other stuff could be in this person JSON? A JSON with a name. I love it. And what's the name going to be? Nah.
Malcolm said Clark Kent.
Clark Kent, dig it. Thank you. Clark Kent. There could be other stuff in here, right? Other stuff. I'm sorry? Ooh. So if I want to create a person out of this JSON, I should make sure that people is codable. Right? I've seen this before. All I'm doing on lines 9 through 13 is being really lazy and not going and getting a remote JSON and pulling it down. Now, how can I decode person JSON? Any ideas? I could create a function in person called getPerson. I dig it. What's that going to return? I'm just going to return a people. All right. Let's see. let person equal try to decode from an instance of JSON decoder, decode, I don't know what to do here. What type do I want this to be? People.self, what is that? It's a little different than that. It's indicating the type, the specific type. It's looking.
Also have to pass in data.
We gotta pass in data. Does anyone know I can turn this string into data? I don't know. Swift data object from string. String to data and back. When converting a string into data, the return type is optional. Interesting. Let cafe data equal, I can just say that string dot data using, what's this UTF-8? Unicode encoding. Strings use Unicode internally. Did you guys know that? Strings use Unicode internally. No? You didn't know that? You never seen like the like that, and then the that, and then the that. Strings are made of what? Strings are an array of what, ultimately? Characters. Characters, what are they made up of? Do you remember the really fun name? Not quite. Oh man is right. Extended Unicode. Unicode extended grapheme cluster. What is a grapheme cluster? I don't know. When you hear the words grapheme clusters, the first thing that springs to mind is a breakfast cereal. Yes. Unicode is a standard that's shared across web languages. And that's good for us because we are getting information from the web in a type that is not native to Swift. So our decoders have to do that. The nice thing is, using data, which we've done before, we can translate it specifically using Unicode encoding. So we can say, listen, like really, like this information might be from aliens on the moon, but I have connected a computer to it, I've found its IP address, and I've gotten a response that includes some data, and I want to try to just, like, can you try to use Unicode encoding so that I can use it? So really, it could be little green, like, 2'3", like, squares on the moon that made the computers and uploaded the data in a language you don't speak. But if the data they're sending you back can be decoded using Unicode, you don't have to worry about how they made it. So this data object is super powerful. All right. I want to turn this string, person.json, into a data object. How do I do that? Check this out. I could do this. Isn't that cool? That's really lazy, right? Now a better name might be person.json data. How do I get that data into this static function? How do I get anything into any function? Type it. I need a param. Thank you. So get person needs to have a param. What should that param be, Liana? Sounds great. What's the type of data? Oh, yes, it is. Cool. Now let's see what it protests. It's going to protest a few things. Errors thrown here are not handled. What does that mean? Handle it with a do catch. Do this. Okay, do that. Catch. Do this and catch. What am I catching? This is so important. When we use a do catch, what are you catching, Levi? You're catching errors thrown. Errors thrown. In this block, there is a piece of information available to us that we haven't even declared. Eric. What is the name of that variable or that constant in this catch block? Say it a little louder. So we have something called error. So in this catch block, we can throw an error. I know I've done this a bunch of times. You don't have to trigger a fatal error here. You probably shouldn't. We're in a learning environment, so I've just made the app crash when things don't work. You might instead trigger like a UI alert or something else. So in this do block, I'm trying to decode some data. Then let's return that person in the catch. We'll print couldn't decode. Let's see if this works. Missing return the function returning people. Dang. I guess I could make people optional. Say return nil. Come on, buddy. Oh, nice. Why isn't this doing anything? Going back all the way to week 2. Yeah, gotta call it. So, in order to call getPerson, which is a static function, Crystal, what should I do? I know, but can you tell me what to type? So just like that. Yeah. Okay. Person. What does this thing mean? It's not necessarily about the scope, but I'm thinking more would I call this on an instance of people, or would I call it on people itself, the type? Cool. So let's call it on people. So people.getPerson, and this getPerson needs an argument. Let's see what that argument is. People.getPerson says it needs data. What variable should we give as this data? Person JSON data. All right. Let's see what happens. It's optional. Let's be really lazy here and see what happens. let's see. If that's the square. It shows me that on this line is a thing called Clark Kent. We did it. Right? Did we do it? No, not yet. Tia, we didn't do it? Couldn't code? Why not? Tell me about your variable called person JSON data. Is it a valid JSON? That is such a good question to ask back to me, but I'm going to have you ask it to yourself. Needs opening and closing braces or curly brackets. I'm sorry. And you also need this comma between each key value pair. Man. Return nil? All right, let's take 3 minutes and wander about. B. That's the function. What?
It's just like play graph, there's a value.
You gotta randomize.
Okay. Check this out. Check this out. Isn't this cool? Did you know that a string has to have a quote at the beginning and the end of it? Did you know that? Did you know that a string has to have a quote at the beginning and the end of it?
Yes.
Did you know that a string has to have a quote at the beginning and the end of it? And another thing is also that a string has to have a quote at the beginning and the end of it. I'm picking on everyone because this is something you're going to see all the time when you're working with JSON, because you're going to be creating your own JSON at some point. You have to keep in mind that everything that opens has to close as well. So an opening 3 quote has a closing 3 quote. An opening curly brace has to have a closing curly brace. An opening quote has to have a closing quote. This string is very different than this string. This string, if you look at line 20, very different than that string. Right? It's incredibly different. So I just want you to keep that in mind. Because with JSON, I'd say like 85% of the errors you get are going to be just the punctuation when you create one. All right. We are almost there. We're almost ready to get stuff from the internet. Let's take a 7-minute break. I don't think there's a midday check-in. There is not a midday check-in.
Go over dates.
Now, I'm glad to review it. It's not, I don't think it's worthy of a full lesson, but I can show you how to use it. Maybe this afternoon. Yeah. It was on there because it was just floating around there. It was more the thought of when should we explain dates as opposed to like today is the dates lesson day.
Yeah, because like, that was funny. I was like,
Wow, okay. See how it is.
Dates. Ooh, what's that? Oh boy. Oh boy. Oh boy. Do you want to sit here and I'll sit there? What? Oh. Hi everyone. Look at this.
Neat.
Awesome. Cool. Here is a string pointing to a location on a computer somewhere on the internet. If we look at Postman, goes ahead, gets us one big old blob. Within it is a key results, which is an array of blobs. This is the random user API that you used before. you feed to it, or you give it a parameter in its URL called results. It says, what do you think this 5 is? Nima. Yeah, what do you think that 5 is indicating? 5 whats? Adam, I can see you under that thing. What? Cool. How many users do you think we are requesting? Yeah. So this parameter is saying, I want you to give me 5 results, 5 users. I'm hitting the random API, give me 5 users. I might create a unit test seeing if that gives me 5 users. I'm not going to do that right now. Instead, I'm just going to show us how we get out of Postman. Sam went from nodding his head to shaking his head really quick. So, you've seen this URL before. You've seen it when you were checking out the file to a JSON. Yeah? Cool. Thank you. Now we are doing it with a URL somewhere out on the internet. So we're saying, here's a thing out there on the internet. I've included in it a protocol. How to do that. Neat. So my URL includes how I get the thing. And say I want 5 results. Now here's the big old fun thing about URL session. URL session is a class. In that class definition is this variable called shared, which is itself a URL session. So inside of URL session, the class itself is a class variable, which you can think of as similar to a static property called shared, which is itself a URL session. URL session has an instance of itself in its own definition. This is called the singleton pattern. What? What's a singleton? URL session provides a bunch of ways for you to create a new instance of URL session with specific properties and specific ways to use it. But it also says, if you want, I've got this property on myself that is a URL session. I have this thing called shared, that in any file, in any view controller, in any model, if you refer to URL session.shared, you are specifically referring to one URL session. So it is a shared URL session across your whole app. So by design, URL session wants you to go ahead and say, hey, that thing you're going to go use to get some information off the internet, you don't even have to create one. There's one in my definition. There's a singleton of URL session in my definition that if you want to go and do something, just call an instance method on that shared URL session, on that singleton. So in any file you're in your app, because you're going to use the internet in probably more than one place in your app, right? In any location, you can use URL session.shared as an instance of URL session. And that's intentional. Because if you want to use the internet, it's good to use that all from one place. If you want to have an internet connection or some object that is mediating how you're connecting with remote computers, so computers at different IP addresses, you probably want one central location where that's happening. And you can do that with this singleton, that shared instance of URL session.
That instance is referred to as a singleton.
So when in the definition of some class, there's an instance of that thing in there, that's the singleton pattern. So this is a singleton of URL session. You'll see it often. Well, you will see it in similar situations. You will see it when they only want you to have one connection to the internet, or they only want you to have one way that you can access a database. You might define a whole database, but then it's weird, right? It's weird thinking about a class definition. If I want to create a whole database, a place that holds a whole bunch of information, so I want to be instantiating a new one of those in a whole bunch of different files. It might be easier to share one resource, to use this singleton pattern, to just have one database, or in our case, just have one internet connection. So now there is one internet connection, that's singleton. Let's look back at URL session, just in case something gets confusing a little later on. Is URL session a reference type or a value type? It's a reference type. So once this has been instantiated, no matter where you refer to it, it's pointing at the same place in memory. So that shared is actually only one object. It's not something being copied or duplicated multiple times. Shared exists in one location. So you are literally, throughout your app, when you use the singleton, it's not that you are instantiating a new object every time called URL session.shared, it's that you are looking at one place.
So in this situation, that money.
URL session is like a little broader than that. Think of this as like the connector. You're looking at one connector. Want to use multiple URL sessions or URLs? You can do that. So shared, what we're going to look at now is shared has an instance method called data task. And data task is just a method called on an instance of URL session, right? So I could call this multiple times for multiple URLs. Let's make it work for one first. This data task, Sunny. Throughout your entire application.
But what I'm seeing that this is like an instance of URL on it to class URL, the overall class URL.
So shared itself, though, think of it as, let's do it like this. Shared in this context is the same thing as having class fruits and a class seed, a class fruit, class seed. Class has got bar taste is yum. If there's a class variable here called seed, it's just a seed, then think of it like a static property almost. This is an instance of seed. I could have this be fruit. Because that makes it, well, you tell me. Class is similar to static in that it exists at the class level. And so for a URL session, think of this shared as just a static property that has been declared in the definition of a URL session that just so happens to actually be an instance of URL session.
Oh, so you're not using it on an instance URL session, it creates an instance here.
Yes. Like when you, literally once you type URL session.shared, it is referring to an instance that already exists. You're not initializing it. Singletons, yay! What? Is that out of fright or excitement? Is that out of fright or excitement? Ooh, okay. So, on a URL session, we perform a data task. Let's go find out more about what a data task is. Data task. Data tasks. Send and receive data using NSData objects. Data tasks are intended for short, often interactive requests. Upload tasks are similar to those. Download tasks, blah, blah, blah. We're generally going to be using data tasks for everything we do. We're not going to be sending whole files. We'll probably be sending strings or JSONs or getting strings or JSONs in return. So chances are we will be using a data task that gets encoded and decoded throughout our app. So data task is just calling a data task. It's saying, let's start performing a data task. The easy part of this is with a URL. So you have to tell it where the location of the resource that you're attempting to perform the data task for is. What does this completion handler look like? What does it have the format of? There's a word that everyone knows and loves about this thing. Anthony. Completion handler. What is the format of that? This stuff. You've made one of those before. Got a tuple that returns something. It's a function, and there's a special name that we give to this kind of function that doesn't have a name, Kimball. That's right. The completion handler is a closure. Everyone stand up and celebrate. Okay. Completion handler is a closure. Here's the format you will usually see for this kind of closure. Instead of putting it all within the parens here, you remember there is trailing closure syntax. So they'll usually say with URL, close paren, open paren for trailing closure syntax. How do I refer to here? Damn it. Say it again then. Do it. What are we doing? Cool. It could do it for us. Guys, I want to do that. Fine. It's okay. Okay. One last time. Thank you for that. If you have highlighted the signature of this closure, hit enter. Look at it automatically sets it up for you. I'm so angry. So this data, URL response, and error, what are they doing? What do you think those are for? Ayla, what do you think those three things are? Cool. They're all optional too, right? So data, what is that? Cool. Data is the data we're retrieving. URL response. Anyone got an idea what that might be? Is that what the code is? Let's find out. Swift, URL response, URL response. What is that? It's a commonly used subclass. Metadata associated with the response to URL load request, independent of protocol or URL scheme. They don't contain actual bytes. Instead, the data is returned a piece at a time through delegate calls. Oh no, I don't know what that means. Expected length of the content. I guess it's a little more than just the response code, but there's something in there that maybe we can try out. No. So the cool tip I just got was if you have this whole signature here, you highlight it, so it's blue, and you hit enter, it shows that format for you. So it automatically creates the syntax for your closure. So data retrieve. Nope. URL response. Response. What is this error? What do you think that means, Allison, as you go? Nice. So it's an error in your data task. So these are three values that can be used as completion handlers of your data task. Completion handler, what do you think, when do you think this closure is getting triggered by your data task, if it's a completion handler? Nima. When it's completed, that's right. So after data task has gone ahead and performed whatever it needs to do, this handler is getting triggered. So it could happen asynchronously, because we sent out a data task to the web. We said, go to this URL, do something for me. And then whenever that task is completed, this closure gets triggered. So it could be right when we do it. It could have gotten stuck in those tubes in the internet. We don't know how long, and that's why we have a handler. We handle the completion of our data task here. And what we're handling is three potential options. The nice thing about this URL session is it interprets the actual response. So it interprets a big old blob of information like Postman does. No. Postman has to receive this information in a certain way. It doesn't just get a JSON, but it's doing an easy thing for you, and it's turning some response data into that JSON that you see. In the same way, an instance of URL session, so for now, this singleton gives to you in its completion handler the data it retrieved, response information, and error information. It's doing that work for you. Say thank you. Thank you.
Thank you.
Thank you. Cool. Let's see. We don't need that anymore. Okay. It's doing that for you. What do you think data is? Sorry. I'm being facetious. They tell you what data is. Data is of type data. So they have decoded that JSON for you. I'm sorry. They haven't even translated that information into JSON. Instead, it's just data. It's just the bytes that it exists at, which is great because in the past, we've had to go and we take that data and say, I'm going to get you from a JSON file, and then I'm going to convert you into data, and then I'm going to decode you. We don't have to convert any JSON into data. We just got data in response. So the reason to know about JSON is that when you look at Postman, this is the format it's going to arrive in, but our code will not see it in that way. Our code will be at the next step of the decoding we've done so far. It will have this JSON already in the format of data. So just a series of saved locations, a series of bytes. And all we have to do is decode that data object in order to get our random person. So I'm going to go look at my model and just make sure, name has to be of a certain type. So I'm going to change up my name model here. Name is not a string anymore. Name is a name. So I'm going to create a struct internally here. So this is just a struct inside of people, which means if I try to initialize something that isn't people.name, it's not going to exist. It's weird, right? I need name to be codable. I need name to have a title. I need name to have a first. And I need name to have a last. All right. So when I hit this API, I want to decode 5 people who have a name property that itself has 3 properties, title, first, and last. That's what we're going to do with this API call. So in this data, I'm going to try to first check if anything went wrong. Okay. I changed up the model so that name is no longer a string, but name matches the format of the JSON from the random user API. So name in the API is actually an object. So I had to create another struct called name to use in people. This struct could have existed out here. I'm doing it in here because right now I'm only using this name struct when I'm making a person. Think of it almost like a private struct because its scope is only within people. And I'm doing that because I only want names for people right now. This guy?
Yeah.
Oh yeah, it's definitely going to conflict. Yeah. That's a good point. Sunny. Yeah.
If it were to interact or if it makes sense to get outside.
If I needed it in another location, I would do it outside. Otherwise, like if nowhere else in my code needs a name, I'd probably just do it inside the person.
So can we go back to the JSON? Like
Yeah.
the
Hang on, Michelle first. That's a great question because I was not paying attention. Alex, let's look at the JSON. No. Okay.
So then in our people struct, right? So let's say we want to
Think about it like how you scope your private variables. So a location is probably the same all over the place. A location is usually street, city, state, and so on. So you might make that outside the struct. The reason I'm making this name for people inside the struct is that businesses might have a different type of name. Businesses might not have first and last properties in them. But if I refer to a name in a business, I might make that a struct for a business. This is not like a universal structure for a name, like just thinking about it kind of highest level. Locations are pretty consistent throughout. Locations refer to a place. Unless I really want to get like abstract and say, well, URLs are locations. Then I might make this location just within like some struct referring to like, I don't know, physical matter. But the reason I did this name here is just name could be defined differently for a different object. Neat. All right, so to prove Tia's point, if I try to decode person now, my JSON data here is broken, so I might have to change that up to make it work. I'll say first is Clark. I'll say last is Kent. Let's see if that works. Couldn't decode it. Oh no, why? Got a name, I've got a first, a last, Clark. I need another property called title, which is Senor. I don't know how to make the enye. I don't know how to make the enye, okay? Leave it alone. What? No, but oh. I love learning. Thank you. Thank you. Cool. Wow. Now the JSON is of the proper format. Yay. All right, now let's make that work with real people. Or real fake people. What? Okay. All right. So, I'm going to call this data. I'm going to call this error. I'm going to call this response. You can just use that format all the time. Just do it. We're always referring to the response. We're referring to the completion handler of a data task. We are referring to the data response and the error. What do you think? That's right. Why? Yes, but why is this always going to be in this order? Because that's the signature of this closure. Just the literal order is data response error. So you can trust it every time. Look, it's Ray. Thanks, Ray. Okay. So when we make a data task, do you think we should try to use the data right away, or should we make sure everything went okay? All right, cool. I'm going to guard let error equal error. What am I doing here? Please help. Error is an optional error. If I'm guarding to make sure it exists, so if error exists, what should happen? There's an error. Cool. this is not what we want to do. We want to say guard let error equals nil. Else, let's just make a fatal error. We're not going to deal with response right now for a little bit. I'm not going to do that. I don't want to do that. Don't need a let. Guard that error is nil. Otherwise, if error is not nil, we have an error. Crash the whole app. Then I am going to guard let data equal data or kill the app. In an ideal world, if you have checked for an error and it doesn't exist, there should be data. But if at some point you're going to be using data and you need to unwrap it, you might as well guard beforehand and make sure that it does unwrap. Yes. So by design of this data task, again, its completion handler should logically say, or it should include in its errors. If there is an error, one of those errors should be couldn't get data. One of those errors should explicitly be that. So we check if there's an error. If there's no error, then we should know that there's data. But data in the signature of this completion handler is still optional. And so if we're going to be unwrapping that data to use it eventually, which we will, because that's how we decode JSON. If we're going to be unwrapping it, we might as well do it right now to make sure there's no problem with it.
On 37, you're just checking to make sure there is data. That's what you're saying.
On 38, I'm checking to see that there is data. On 37, I'm making sure there's no error. So error is itself a type, like we've seen before. And we're just making sure, like, this part of the tuple is an optional error. I want it to be nil. Allison. You might do one of many things. In the app you are making this weekend, no, sorry, this whole week, not this weekend. Wouldn't do that to you. It's a holiday. You're going to be getting stuff off the internet. You're going to be getting stock prices. Say you can't find the stock price. You probably wouldn't crash the app. You would probably say couldn't retrieve. You know, you might present an alert. But this has no UI. This is just us dealing with data right now. So I'm saying right now, for us, we'll kill it. Also, it's really tedious handling like UI errors, and I don't want to do that right now. Aaron.
I was thinking, I've seen this before, create like, errors.
You could definitely do that.
And it makes sense to include like 400 errors, even errors. We can incorporate that into that.
Yeah. You'd be looking at the response if you got an error, and you'd see what type is that, so I could respond in the appropriate way. You might try to resend the request differently. You might try to reformat it. You might have your code do that, so that you don't have to rewrite the code to make it work. There might be some correction it does. Sunny. Errors. The errors are going to be a little more descriptive. They're going to say they're errors that are created by this data task function. So this data task function and its definition, it is going to go ahead and create the errors for you. This is just its signature. In its implementation, it responds to what it gets from that remote source or that URL. And it says, oh, that created an error like this. So now I'm providing to the person using my function, I'm providing to them an error with that information. So it's literally a thing called error, but it does the interpretation. It might say, yeah, unauthorized. It might say payment required. It might say something else though. It might be like the format of this did not work, or like JSON could not be like turned into data or something like that. Neat. All right. Okay. So we've handled that stuff. Now we have done the decoding stuff before. We set it with get person. If we have data, we could say something like, I don't know. What do you want to do? People.get person for data. What do you think that's going to do? I don't know. Let's run it and see. Tilde. The playground could not continue running because the playground source did not compile successfully. We're not calling this. It's not doing anything, right? We need to tell our URL session to do its session task, go ahead and call a function on that actual task. Don't worry about how I just got where I was, but you are dealing with an instance of URL session. That instance of URL session has this function called data task, which returns something called a URL session data task. A URL session data task is of type URL session task, and a URL session task has a function that you call on it called resume, another one called suspend, one called cancel. These are all you telling the task what to do. You have to trigger this data task by calling resume. How do you all feel about that? This has to be called by calling resume. Now let's figure out the use of unresolved identifier URL session. What? Why? Huh. Let's ask my friends. Excuse me. What framework is URL session in? Anyone got any ideas? URL session is in Foundation. It's part of Foundation. I have not imported Foundation, so it doesn't know what the hell URL session or URL, for that matter, are. So what's that? Let's try running it now. I hope it works. Oh, I sure hope it works. Oh, it couldn't decode it. Dang. Oh well, let's just give up. Nope. Almost there. Phoenix. So they share a lot of things, including like the basic like arrays and dictionaries and stuff like that, but they serve different purposes. Foundation includes a lot of this stuff that would never occur in the UI, which is why it's in a different module or a different framework. UIKit is, we've used them kind of interchangeably because we have generally not needed to get specific functionality, but Foundation doesn't have a lot of things that are in UIKit, right? Foundation doesn't have view controllers. Like, They overlap in some ways, but are different in some other ways. What do you guys want to do to fix this? Sunny. Yeah. Couldn't decode. Oh, there's an error here. Let's interpolate that error. Name. Coding keys. No value associated with key, coding key, name. Interesting. Name. Name. Name is a name. Name is a title. Name is a first. Name is a last. Let's go look at our JSON. Name. Name. Oh, no. There's another level of that. I need to decode using a wrapper results in order to access my 5 people. Neat. So let's make, I could make all these things inside of each other, but I'm feeling lazy. So I've got people wrapper, which is codable, which has a property called let people be an array of people. It really should be person, so I'm going to change that throughout. We should refer to them as singular. Person, wrapper, an array of person. Well, I'm going to change it in just a sec. Okay, person dot get person. I want that to be a person. I'm going to say that we get persons inside of a person wrapper. And then I'm going to make sure that this is of type person, wrapper.self. And you had a good point. I called this people, but the key here is results. How can I change it so that wrapper. How can I make sure that it's decoded in the right way there? Sunny. Hang on. Hang on. Yes, please. Yep.
Which is, I've seen us use person wrapper as the one wrapping the whole array, and I've seen us use it as the array. So is the term wrapper the outermost one? So then, I personally would keep that as person and have the person wrapper outside of it.
Like this?
Oh, wait, no, never mind.
Okay, how do I make this people?
Use that to,
Let's do a private enum. What do you want to call that private enum? Yeah. Tell me what coding keys should know. Yeah, it should be strings. And they should conform to coding keys. All right. There's only one case here. It's people. Let's set a raw value for that. What's that going to be equal to? Neat. So I decoded this in the way I want because I'm in charge and that JSON can kiss my... This needs to be singular when you're talking about coding key. When you're talking about decoding keys, make sure this thing here, which is a protocol that your enum is conforming to, what? Make sure this is singular. The protocol is called coding key. The enum you are implementing is coding keys. It's got one thing. Now I gotta make sure that I do this the right way and rename everything. I'm sorry, I'm gonna call this people wrapper, which has inside of it multiple persons. Because multiple persons is a people, in my own personal opinion. Cool, let's do that. People wrapper. People wrapper. All right, let's run it. You ready? Oh no. Dang. No key associated with value, with key coding keys. Results. Int value, nil. Results. I never changed my JSON. Damn. Let's do this. Yay. Now I changed my JSON. Neat. What do we got here? What? 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 Oh my god. All right, well, this is going to return something. After lunch, we're going to see how we can deal with this actual data that we get from the response. So now I'm going to say var, there is group of persons, which is an array, which is a people wrapper. And then I'm going to say group of persons. It's a really bad way of doing this. Of persons is equal to that. Shut up. I guess we'll make it a type of that. And what do you want to do? What optional value of people wrapper must be unwrapped to a type? Oh, okay, fine. I guess we could do another guard statement. Look how much we have to protect against things going wrong. Guard, let people equal that stuff. Group of persons equal to people. Neat. I don't know, let's see if this works. Print group of persons. I broke it. Damn. I love when Olympia and Aram start leaving right before lunch. They're like, I'm done with this.
And again, don't start on the microwave.
Oh, wow. That's betrayal. Fatal error. Oh, no. What happened? Variable defined here. Variable used before initialized. What? All right. Let's do it like that. That's not going to work. What? Oh, man. I just want to print out people. So what we have done is we've gotten that info off the internet. Now we need to talk about how you're going to use it in your app. So you've decoded something from a URL, and now we need to talk about something called result, which we have seen before. Yeah, I'm going to put this on GitHub right now. So we're going to come back at, I'm thinking 3. How do y'all feel about 3? Oh no, I have a meeting at 3. We're going to come back at 2:30. We're going to come back at 4 o'clock. That's not, this is work, friend.
I saw one being worked early.
That was an interesting workplace you had there. That must have been nice.
There are some companies that are only the 40
All right, let's come back at 2.
4.
I can't do 3. It's 2 or 4. We're coming back at 2. Coming back at 2. We're going to talk about results quickly. We're going to talk about the day-long project, the week-long project. And then you're going to get started on that week-long project until 6:01 p.m. today, right? Oh, 5:59. Okay. Mariel's on a different schedule than us all.